Hello everyone and welcome back to my channel. As you remember, we did the practice problem 3.2 in the previous lecture, and we're supposed to solve this problem by using Cramer's rule. So the problem was to find voltages across node 1, node 2 and node 3 using the nodal analysis. And now we find three equations and we have three unknowns. We are going to solve it using Cramer's rule. First of all, we are going to write this equation as form of the matrix. That means it is 5v1 minus 2v2 minus 3v3 is equal to in fact this one was 24. Yes, 24 4v1 plus 5v2 plus 0v3 is equal to 0, and 3v1 minus 6v2 minus 4v3 is equal to 0. Now we are going to form delta 1 and delta 2. In order to form delta, you are going to take these elements on the on my matrix, my main matrix, which is 5 minus 2 minus 3 4 5 0 3 minus 6 minus 4, and then I'm going to have two extra rows, which is exactly the row number 4 copied from row number 1, which has 5 minus 2 and minus 3 on it, and the fifth row is copied from the second row, which is contain 4 5 and 0. Now I have the following rules. First of all, I should consider all the elements on my main diagonals. This is one of my main diagonals, this is the second main diagonals, and this is the third one. What I'm going to do, I'm going to multiply all the elements on the main diagonal and I add them up, meaning that 5 times 5 times minus 4 plus 4 minus 6 minus 3 plus 3 minus 2 0, which gives me minus 100 plus on the second 72 plus 0. So if you calculate this one, 100 minus 72, it should give you minus 28 on the main diagonal. Now I'm going to find the elements on off diagonals, which are here. So I have these ones. What I have here, I have minus 3, 5, and 3, plus 0, minus 6, 5, plus minus 4, minus 2, and 4, which will give me minus 45 plus 32. And the other one is also 0, so if I do like so, I calculated this is minus 13. Now I'm going to subtract the off diagonal from the main diagonal, which is my delta is going to be minus 28 minus 13, which will give me minus 50. This is my delta. Now, in order to find delta 1, I'm going to do the same thing, but rather than first row, I'm going to replace my vector over here with this element, meaning that rather than 5, I have 24, rather than 4, I have 0, and rather than 3, I again have 0. So again, I should have 5 rows, and you know that rows 3, 4, and 5 is repetition of rows 1 and 2 respectively. So what I have in my first row, so I have 24, and I have minus 2, minus 3. Then on the second one, I have 0, 5, 0, 0, 5, 0. Then on the third one, this element is going to be 0, minus 6, and minus 4. 0, minus 6, and minus 4. Then I copy the first 2 rows again. And 0, 5, 0. And I'm going to apply the same thing on the main diagonal. I will have these ones. And on the off diagonal, I will have these ones. So on the main one, I have 24 times 5 times minus 4. Then the second diagonal, I have 0. And on the third one, I have 0. So the only element that I have is combination of this 3, which if we calculate it in the right way, we should get 24 times 20, which gives me minus 480. Now, on the off diagonal, the first one is 0, the second one is 0, and the third one is also 0, so I don't have any other contribution over here. Now, what is V1? V1, you can find it as the ratio of delta 1 over delta, which is equal to minus 480 over minus 15. Which gives me 32 volt. With the same manner, you can find delta 2 and delta 3. Let's go for delta 2 and delta 3. For delta 2, what we have, we are saying that we are going to replace now the second columns by the vector that I have on the right side of my equation, and the rest is unchanged. That means I have 5, 24, and minus 3. I have 400, and I will have 30 minus 4. fourth row is the copy of the first row, and the last row is the copy of the second row. And again, I have to multiply the elements on the main diagonal together, which in that case is 0, and subtract the one in the off diagonal, which also I only have this one, which is minus 4 times 24 times 4, which, if you calculate it, 16 times 24, which gives you 300. Your delta 2 is 384. And if I want to find V2 is nothing but delta 2 over delta, which is 384 over minus 15, which gives me minus 25.6 volt. And finally, I can find delta 3. So you get the pattern. I'm going to write on the new page. So what is delta 3? Delta 3 can be found as replacing the last columns by the vector that we have on the right side. So I have 5 minus 2 and 24. I have 4, 5, 0, 4, 5, 0, and I have 3 minus 6 and 0. 3 minus 6 and 0. And again, I'm going to copy the first two rows here, 4, 5, 0. And what I have, I'm going to have the diagonal one. So the only non-zeros one is 4 times minus 60 times 24, which gives me minus 576. And in the off diagonal, I will have these ones, and these ones. So my off diagonal is I have 24 times 5 times 3, which gives me 360 on the off diagonal. Therefore, I can subtract the off diagonal from the main diagonal, and this one is going to give me 936 minus 936. And if I say that this is my delta 3, so what is V3? V3 is nothing but delta 3 over delta, which is equal to minus 936 by minus 15, which gives me 62.4 volt. This is all the voltages that we need to find. Thanks a lot for watching this video, and see you next time.